Good afternoon, everybody. Wanted to give folks a tour of Haygor, and we'll get started here by going out on the shop floor. Let's go. All right, we'll make a quick stop right here in front of our R&D lab, right here to the right. This is our R&D space where we do testing on our thermal guardian and temperature compensating systems, as well as any other innovations that we have that we're working on. We also have 3D printers in there as well, where we're able to print components of manufacturing, that we're able to 3D print them first for fitment. We also print fixtures for our machines. So we're able to do all kinds of testing here in the lab with 3D printers, as well as the temperature compensating and thermal guardian. This is our patented thermal guardian attachment for all of our diaphragms that can be used with most all of our diaphragm seals. This is a high temperature application attachment for diaphragm seals. It protects the instrument from temperatures up to 1200 degrees. And now we'll take you out on the shop floor and show you where this is actually made. Okay, so this is our shop floor. This is 28,000 square feet in total for the facility, with about 7,000 square feet in the front office area for administrative, the R&D lab, account management, and conference room space and office space. And the rest of that space is dedicated to manufacturing, repair, and remanufacture of instrumentation. And I'm going to take you through a walk here on the facility to kind of give you a flow of how things work here in the facility. The orders start out in our account management area, and then once they are entered into our manufacturing in our MRP system, they actually come out here to the floor where they are processed. So let's take a look at how that work flows through here. The work actually starts with the account management, starts here with the scheduling department. So at that point, we will take that order and we will determine if we need parts to be made or if those parts are on the shelf. Part of what makes Haygor unique is our fast delivery times. And the way we accomplish that is by having most of the high running parts on the shelves. And we'll see that here in just a moment. The fastest or the longest time that we have in the manufacturing process for our diaphragm seals is the machine shop. And if we have those parts that are on the shelf, then we completely bypass the machine shop, and it allows us to get orders out much quicker, with expedites even being hours, anywhere from 1 through 5 day expedite time, with our standard delivery being 5 working days. So let's continue the flow of the work. Once the orders are scheduled, then we'll follow the flow of the work through the shop. Okay, for diaphragm seals, as you can imagine, most everything starts as bar stock. So you can see behind me, we have bar stock here of all different diameters and all different materials. Being in Houston, we're able to get even exotic bar stock either same day or next day. So we don't have to search for the exotic materials. We also stock a fair amount of exotic materials here in-house, so that when we have an order, we're able to process that quickly. But it all starts here with our automated saws. We have 2 automated saws that we try to keep running 23 out of 24 hours a day. We're able to load up large pieces of bar stock, and it will cut the different thicknesses according to the different stock orders that we're producing. All of our bar stock that comes in is material traceable, so we have material IDs on all of it, and that material ID follows the bar stock all the way through the process of machining. Okay, so once the material is cut, it is staged here with its paperwork as well as the barcodes for the material. So this paperwork will follow the order all the way through, the stock order all the way through, and it is now ready to visit the machine shop. All right, this is our latest addition to the Haygor CNC fleet. This is our new DNX twin turn machine. It is also accompanied by a Halter robot that will load and unload the billets of material. So the robot will take this blank material, load it into one of the spindles of the DNX, and then the DNX will perform all of the operations of both a lathe and a mill all in one machine, and then the Halter robot will then remove the finished component from the opposite spindle and place it in this carousel here. So when we are finished with this machine, the part will be completely finished. All chamfering is done, and the part is ready to be QC'd and put on the shelf. Now obviously this is a high production machine, so we will run a large number of parts through this machine, and we're able to actually run this machine overnight. It's fully automated, including multiple tool changes that can be done while nobody is here. So we're able to continuously run the machine for 24 plus hours to finish up a complete run. Also with nobody here. There won't be anybody standing here while the machine is running. So, and now we'll take a look at the rest of the machine shop as well to give you a quick overview of what the rest of the machine shop holds. Next in the machine shop is what we call our Quicktech machines. This is another step of automation for the facility. These machines are equipped with bar loaders so that we can load bars of material into the machine, and actually the machine is able to pull the material into the machine and continuously run different parts for the machine shop. So once again, these are high volume machines as well, and we're able to run these up to 36-40 hours in a run. So we will set up and run large quantities of parts on these two machines, which also take the place of a standard lathe and a standard mill operation. So mill and lathe operations are able to be completed on one machine. So once again, when parts are finished on this machine, they are finished parts as well and are able to be QC'd and put into stock. So let's continue our walk through the machine shop. Okay, so these machines right here are our 5-axis mills. These machines were put in place primarily to run side flanges for our diaphragm seals. So we will typically replace the manufacturer's side flanges with low volume side flanges that we manufacture, and they're really done on these two machines right here. Once again, combined with two robots so that we're able to load the slugs of material, and when it comes out, it's a finished piece. So we have these two robots here And then we have the 3 halters in the back that are associated with the Doosan's mill and lathe. So in the machine shop on this side right here is standard lathes and mill pods. You'll have a lathe on one side and a mill on the other. So once again, this is for larger quantities of products as well. And then in the very front of the machine shop, you have 3 machines. You have a lathe and a mill and a combination machine, all CNCs. That is our job shop. Okay, so anything that is not in our catalog or has an exotic material or a special dimension on it will flow through that job shop. Once again, it's a small job shop, but very fast in that we're able to process those unique orders through that job shop quickly. So this is on this side of the machine shop. So everything over here is manufacturing for diaphragm seals. As I mentioned earlier, what allows Haygor to process orders with a standard 5-day delivery and same-day expedites within hours is our stock of high-running components. These components are finished in larger batch quantities. They're QC'd, they're labeled with barcodes, QR codes, and staged on the shelf, so that when the orders come in, we're able to go through and pick those orders with the materials needed, and it completely bypasses the machine shop from an order time standpoint. The machine shop is what takes the longest amount of time with the order processing, so we're able to cut all of that out and just have the components ready to go. Our inventory management system allows us to know what the high running materials are, so we're able to keep a min and max of these on the shelf, and that way when the order comes in, we're able to pick that material and send it through the rest of the process, which is welding and fill and calibration. So this is what allows us to do what we do with our quick delivery times. That also includes stock orders of exotic materials. So we're able to stock some of the high running exotic materials. We know what runs, and we'll actually stock those on the shelf so that when the order comes in, we have it ready to go. So let's move on next to our diaphragm room. Okay, this is our diaphragm room. This is where we punch all of our diaphragms. Notice it's in its own enclosed space because we try to keep this away from any dust, any manufacturing dust and debris that's generated, because any of that translates onto this diaphragm when it's punched will actually punch that into the surface of the diaphragm. So we try to keep this area cordoned off and clean. And this is our press that we use here, along with our proprietary punch and die system. We start with foils of different types, mostly 316 stainless, but we also do the exotic diaphragms as well. But it all starts with a foil material, typically 3 mils, and we will cut squares of that out, and in one operation we will completely form these convolutions and features of the diaphragm. All in one step, we will form them and punch this out into a finished diaphragm. These diaphragms are also production produced as well, so we will get a stock order for these diaphragms, and we will set up and punch large quantities of these at one time, and they're stocked in welding where they're put together. Okay, the next operation for our diaphragm seal manufacturing process is our welding department. So this is our welding department. So now all of the parts have been pulled into our job buckets, and now they're ready to be welded. So this is where all of our structural welding is done. So all of our capillaries, our fittings on our capillaries, also our diaphragm seal welding is all done in this area. All of this welding is TIG welding here, and we do fusion welding on the diaphragms. When we weld those diaphragms onto the uppers, we will fusion weld those with our TIG welder down at the end. And then also we have our resistance welding or seam welding right here as well. It's state of the art. It's really two primary advantages of using the resistance welding when we're attaching our diaphragms to our uppers. One, it's faster, and it produces a superior weld that allows us to weld to similar metals. TIG typically does not like that, so the resistance welding provides a very strong, sound weld when we're using dissimilar metals. So those are the two advantages to our diaphragm seal welding. Every weld that we do here in this shop is helium leak checked. So we'll actually pull a vacuum on the weld and then spray helium gas around the weld. And if there's any type of abnormality in the weld, it will actually alarm and give us 100% QC on all of our welding. Next, now that everything has been welded and assembled, now we move to our fill and calibration area. Okay, the next step in the process for manufacturing is our fill and calibration area, where we will actually fill the system with any number of fill fluids that the customer requests, and we will show you how that process is done right here. Okay, this is our fill station right here. We are actually filling this system right here. Very simple, relatively simple process involving a vacuum pump, where we put the entire system under vacuum, including this is an extended seal here. We're putting this system under vacuum. We're also putting the fill fluid under vacuum as well to degas that fill fluid. And this will stay under vacuum for a very prescribed amount of time according to our procedure. And that it depends on the length of the capillary, the diameter of the capillary, as well as the type of fill fluid that is being used. So once this system has underwent the prescribed amount of evacuation, at that point we will fill it, and it's a very simple process. We will turn off the vacuum, and then very simply we just drop this fill tube down into the fluid, and the negative pressure in the system will actually pull that fill fluid through the tubing and into the system, all the way from the sensor on the transmitter all the way to the back side of this diaphragm that's on this extended seal. That process normally doesn't take any more than 5 to 10 minutes to fill, depending on the fill fluid. But once it pulls all of that fill fluid in, then we simply seal up the fill ports, and the system is ready to be calibrated. Okay, so this is the final part of the fill and calibration process. Once again, the transmitters come from the factory calibrated with no attachment on there, so we have to ensure that once we add the attachment, that the calibration is the same as it was from the factory. So what we will do is we will calibrate these units. We simulate the pressure, the process pressure right here through these fixtures. We will mount the diaphragm seals up and we will simulate the pressure. We will simulate minimum, maximum, and 3 points in between to show linearity of the system. Our controllers up here will automatically track the 5 points of calibration, and then we use typically a Trex communicator to communicate with the transmitter. So if the customer requires any custom ranges or any different ranges than what are set from the factory, we're able to change those settings for the customer and are able to calibrate those new settings. And every system that goes out of this building comes with a calibration report. So whether the customer requests it or not, we ensure that we attach this calibration report with the system. It goes in the box itself and is shipped with the unit. We also keep that on file here at the facility. So now that we're done with this piece, now it goes to shipping, where we package it up, and let's go take a look at the shipping department. Okay, this is our shipping department. This is the final step of our process for manufacturing. We will actually take the product, it runs through a QC process before it gets here, and then it also runs through a final QC verification by the shipping team. So there is a shipping checklist that has to be signed off by 2 people to ensure that everything that is correct with the order, all the way down to the serial numbers and model numbers of the transmitters and seals. So once that QC checklist is done, we will box the product up. We use the 2-part expanding foam to create a nest around the diaphragm seals to ensure that they're protected during shipment. And that way, when it arrives at the customer, at the end user, they're able to pull the foam off, and the diaphragm seals have been well protected in transit. So once again, this is where the final QC verification is done, as well as the final boxing and labeling is complete. Okay, this most of the facility here is dedicated to manufacturing of diaphragm seals. However, this section behind me is dedicated to our repair operations. So most of the operations that go on behind me are bench tech repairs, where we will actually take a customer system and we will repair the system. We will also remanufacture and recondition the equipment, and that's anywhere from pneumatic instrumentation that's no longer manufactured all the way through current instrumentation, where we will just bring it in, repair it, remanufacture it, make it look as new as when it came out of the factory. And that is done behind me, once again, for pneumatic and electronics as well. These techs will repair it and have it ready once again in a standard 5-day delivery, as well as any of the remanufacturing that we will do on the instrumentation. Once again, once it's done here. So once the instrumentation is repaired or remanufactured, it is then sent through the same QC process, and then it is then transported to our shipping department, where we will actually run through the checklist again and prepare the product for shipment in the same manner that we do for the diaphragm seals as well, the manufactured diaphragm seals. Package it with the 2-part foam, expanding foam, so that we have protection for transit. This area right here is our latest innovation. This is our Haygor Specialty Coatings area. And we are able to coat with physical vapor deposition technology various components associated with our diaphragm seals and in other industrial applications where it would be applicable for hardness or for wear capabilities for different materials. So we're able to complete that in-house. We're one of the few facilities in the state of Texas that are able to do specialty coatings, and we are able to do that right here in this room with this piece of equipment behind us. We also have a series on YouTube regarding our specialty coatings that you will be able to review the features of these coatings. All right, thank you folks for joining us on our tour here in our facility, our state-of-the-art, world-class manufacturing facility. Anything that you need, we can help you out, and we look forward to seeing you soon.